Have you ever wondered why every single year we hear about new, stronger versions of the flu, COVID-19, or other viruses? It feels like a never-ending cycle, with experts warning us about infections that spread faster, hit harder, or just seem smarter than before. Why does this happen? What's going on inside these tiny invaders that makes them so relentlessly adaptive? Let's break it down. The core reason is something called viral evolution. Think of it like a high-stakes survival game where only the fittest viruses win. This game is driven by a few key processes. The first is genetic drift. Imagine a virus making millions of copies of itself. Every now and then, a tiny random typo occurs in its genetic code. Most of these typos or mutations are harmless, but occasionally one gives the virus a slight edge, helping it survive and multiply just a little bit better. Over time, these small changes accumulate, gradually altering the virus. Then there's the more dramatic version, genetic shift. This is a major genetic shakeup. It happens when two different virus strains infect the same cell and swap large chunks of their genetic material. This creates a completely new hybrid virus, one that our immune systems have likely never seen before. This is why we sometimes see sudden, dramatic changes in influenza viruses, leading to potential pandemics. These genetic changes result in something called antigenic variation. Antigen refers to the surface proteins on a virus, which are like its ID card. Our immune system learns to recognize these antigens to fight off infection. But through drift and shift, viruses constantly change their surface proteins. It's like they're wearing a different disguise each season. This is why last year's flu shot might not protect you this year. The virus has changed its look, and your immune system doesn't recognize it anymore. With COVID-19, we've all heard about spike protein mutations. The spike protein is the key the virus uses to unlock and enter our cells. Mutations in this protein can make the key fit the lock more efficiently, allowing the virus to infect us more easily or spread faster. This is what made variants like Delta and Omicron so successful. They evolved a better key. But it's not just about the virus changing. Our own bodies play a role. There's a fascinating phenomenon called immune imprinting, also known as original antigenic sign. When your immune system first encounters a virus, it creates a very strong and specific memory of it. The next time you encounter a similar but slightly different version of that virus, your body tends to rely on that old memory instead of mounting a fresh, tailored response to the new version. This can be helpful, but if the new variant is very different, that old memory might not be effective enough, leaving you more vulnerable than you'd expect, even if you've been vaccinated or previously infected. Our modern world also gives viruses a huge advantage. Increased global travel means a new virus variant can hop from one continent to another in just a matter of hours. Crowded cities provide the perfect environment for rapid transmission, and our impact on the environment matters too. Climate change and deforestation are pushing animals and humans closer together, increasing the risk of what's called zoonotic spillover. This is when a disease jumps from an animal to a human. Many of the most significant viruses, including influenza and coronaviruses, originated this way. Climate change also contributes to vector-borne viral resurgence. Warmer temperatures allow disease-carrying insects, like mosquitoes, to survive longer and expand into new regions. This means viruses like dengue or Zika can spread to places where they were previously unknown. All these factors contribute to what scientists call viral fitness advantage. With billions of people on the planet, every infection is a new opportunity for a virus to replicate and mutate. The versions that happen to be better at spreading or dodging our immune defenses will naturally become the dominant ones. It's not that the virus is thinking or has a strategy. It's just simple, ruthless natural selection on a massive scale. This is why we see these waves of seemingly stronger viruses emerge over time. But here's the good news. While viruses are evolving, so is our ability to fight them. Science is moving at an incredible pace. One of our most powerful tools is genomic surveillance. This allows scientists to track the genetic code of viruses in real time, almost like a global weather map for viral mutations. By analyzing samples from all over the world, they can spot new, potentially dangerous variants as soon as they emerge and predict how they might behave. This leads us to another breakthrough: mRNA vaccine platforms. You probably know them from the COVID-19 vaccines. The beauty of mRNA technology is its flexibility, because it's based on a genetic template. Scientists can update it incredibly quickly to match new variants. Instead of taking years to develop a new vaccine, they can create and test a new formula in a matter of months, helping us stay one step ahead. Of course, technology isn't the only answer. Simple public health strategies are still incredibly effective. Things like improving ventilation in public spaces, using rapid tests to identify infections early, and getting seasonal boosters all work together to reduce the overall number of infections. Fewer infections mean fewer opportunities for the virus to mutate and evolve. It's a community effort that breaks the chain of transmission and slows down the emergence of new variants. So, yes, viruses will always evolve. It's a fundamental part of their biology. But understanding how and why they change is our greatest strength. By tracking their genetic drift and shift, anticipating their antigenic variations, and using cutting-edge technology like genomic surveillance and mRNA vaccines, we are no longer just reacting to new threats. We are actively predicting and preparing for them. It's a continuous race between viral evolution and human ingenuity, and by working together, we can protect ourselves and ensure a healthier future for everyone. Thank you so much for watching. If you found this explanation helpful, please hit that like button and subscribe to our channel for more deep dives into the science that affects our world. And let us know in the comments what other topics you'd like us to cover. See you in the next video.